All right, let's take a look at geometric sequences, and we're going to just kind of go through the idea with four terms given to us, the first four terms, that's important. And so we are going to decide first, is this even a sequence or not? So the first thing you have to do, geometric sequences are built on multiplying, and so we're working backwards. That means that we have to divide to see if it's geometric. So we're going to take the second and divide it by the first. So 12 divided by 4 is 3. Okay, so let's test it. Let's see if the third one divided by the second one, 36 divided by 12. Yep, that's 3. So far, so good. Let's test the last pair. 108 divided by 36. If we divide that, we do get 3. And so we can say, yes, this is geometric. That's the first answer. It is geometric. The common ratio we actually just found, slide this over, common ratio is 3 because that is the rate at which the sequence is increasing. By multiplying by +3, we're getting the next terms. Okay, we're going to find the eighth term and the explicit formula. I always find the formula next. And so let me actually, instead of doing that, let me show you the formula on my formula sheet. I'm just going to pull it in. Okay, so here it is right here. We're going to use the explicit formula. This is the simplest one to use right here. And so the terminology can look kind of different, right? A sub n equals a sub 1 times r to the n minus 1. Well, we just found the r, the ratio, right? This is one time when r does not mean radius, it's the ratio. And a sub n, think of it as any number, an, any number. So any number in this, any term in the sequence, right? We're going to use the eighth term in just a minute, but for now, we're just thinking about for any number. A sub 1, that doesn't mean any number. It means the first number. It means, in this case, it'll be a 4 for us. So for this sequence, the first term is 4 times the ratio is 3 to the n minus 1 power. So the n's are going to stay in when you're writing the formula. So this is the formula right here. From that formula, we can find any term. This problem asks us to find the eighth term. So n is equal to 8 in that case. If it had asked us for the 100th term, then n would equal 100. But since n is 8, then we're going to go to our formula. 4 times 3 to the n minus 1 power becomes the 8 minus 1 power. And so we know that's 4 times 3 to the 7th. And just realize this is not 12 to the 7th. This is 4 times 3 to the 7th. You know, order of operations says that we would do the exponent first. So grab your calculator and see what you get. Okay, so we've got our answer here, 8,748. I went ahead and put 12 to the 7th up there just so you could see that the difference, right? That's a huge difference. So the eighth term is going to be 8,748, not that huge number. So just remember, order of operations is 3 to the 7th, and that's times 4. So, okay. So stop and think about that for a minute. Our sequence starts at 4. And by the eighth term, it's at 8,748. Geometric sequences grow really fast, very quickly. These are exponential. And so that's an aspect of it. Now it wouldn't grow as fast as that, 12 to the 7th, but it does grow very quickly. So I hope that helps you with geometric sequences. See you next time.